Hi, Ben Pouladian here from BEP Research, live at NVIDIA GTC 2026. And I have here with me Adel El Hallak, VP of AI and Product Management at NVIDIA. Nice to see you, Adel.
Good to be here, Ben. Thanks for having me.
Yeah, it's an exciting time for AI and how far it's come. And I just wanted to maybe start off learning a little about you and your journey and how you got to NVIDIA. And we can then dive into models and software and all the fun stuff that you work on every day.
Yeah, happy to go through that journey. Take you a quick blast through the past. I grew up in Canada, studied computer science, but then wanted to venture out to the world when I first graduated. I ended up working for IBM, based out of Dubai, and there was a large oil company, the largest oil company in the world, that needed to send waves into the ground. And when those waves come back up, they need to be able to visualize those waves. So in 2007, I had to go learn what a graphical processing unit was, right? A GPU was. This is like 2007. And we ended up winning that deal with that customer, right? It's Saudi Aramco, I'm not hiding, right? We ended up winning that deal with that customer, and I became almost like a high performance computing specialist. And came back to the US with IBM, and what happened over the years was, if you fast forward 10 years, that same infrastructure, or these underpinning infrastructure for scientific computing, for high performance computing, for visualization, right, was pretty good for deep learning. And so by virtue of going from high performance computing, where we were doing software for that infrastructure, when deep learning first started, I got an opportunity to work on IBM's first deep learning based product, and just continued collaborating with NVIDIA. And so in 2018, I couldn't resist, and we packed up New York City and moved to the Bay Area.
Oh, wow. Coast to coast.
Yeah, coast to coast. Only had 30 days to do it. And yeah, I've been in the Bay Area since 8 years. I started off by doing NVIDIA GPU Cloud, NGC, our container registry for, at the time, what was our frameworks and what we used to call Joy of Cooking, which was scripts for how we train models. And then we built NVIDIA AI Enterprise, which is a downstream of all the open source software that we provide that is supported, stable APIs, et cetera. And then now all I talk about is agents, because agents as a service is a real revolution that's upon us.
Yeah, I mean, that's something I didn't even have in my prepared notes when I came here. Obviously, in the keynote, there was this huge push on open source and Claude bots, and me personally, I tried a Claude bot myself, but because of the lack of security permissions, I kind of took a step back and was a little afraid about it, because just giving an AI full access without any control, I'm a big believer in AI, but I need to have some sort of control and some guardrails. And I was happy to see that I tweeted about it. NVIDIA was dedicating some security developers and some teams to help secure it for open source and enterprise. And, leading into that, like, how do you see the next iteration of what you guys are doing dovetail into that? Because obviously, leading up into this, there's a big contingent of these models, right? I think the biggest model that caught my attention was Nemotron, right? And then it was like a mid-sized model, and then the larger one came out like a few days ago. And if you look at the ranking that Jensen provided on the screen, it was like in the top 5.
It was the 4th. You're right. Yeah.
Versus open source. So sometimes people are wondering, oh my God, is NVIDIA competing with its customers, or is it giving tools? Because its customers, obviously, OpenAI and Anthropic, are not sharing their weights and their data. But an open source model like Nemotron is open to everybody.
Yeah.
And I think maybe that's sometimes when people say open AI, maybe that's a true open AI. So I wanted to hear what you think about that.
It's a great question. I think, first off, we fundamentally believe that every agent or every system of agents is multi-model, is a multi-model system, so multiple models. And so it's tempting to position and pit Nemotron versus cloud frontier models, when in fact, a lot of the usage at NVIDIA is a combination of both. One of the products that we announced was IQ as part of the NVIDIA Agent Toolkit. IQ is a deep researcher. So I'm not talking about, it's a long running agent but not one that's doing code execution, right? We'll talk about the open clause stuff in a minute. But it's a long horizon agent that goes and executes on a task, spins up a whole bunch of different sub agents, right? And for research, you think, oh, it's just one agent that does sub. No, you actually have an agent that just does facts gathering. You have an agent that does critiquing, like looks for alternatives. You have an agent that looks at different frameworks for how to present the work. You have an agent that does compares. You have an agent, and then you have a synthesizer that brings them all together. That brings them all together. And so, why am I describing all this? Well, that agent deployed internally at NVIDIA uses Opus as a orchestrator, uses Opus as a planner, uses Nemotron for all the specialist sub-agents that are doing the research. And that combination of cloud frontier models with open models that you can customize, that you can tailor, resulted in us being able to win DeepResearch Bench 1, DeepResearch Bench 2, which are two different benchmarks for DeepResearch, right? And so the point I'm trying to convey is that all agents will be a system of models, and in fact, it is open models will augment your agents. It's not one against the other; it will augment your agents. And I think there are times when you cannot, for whatever reason, send data to an API, right? You need to have access to that model. You need to have the full transparency of that model. And so there will be times when folks will say, I just want to build my model with open models, right? The gap in terms of performance and accuracy of open models and cloud frontier models, if you will, is converging, right? Is converging. And so we love general purpose models. We use them all the time. And I think there's a world for both. And all of our agents are utilizing both.
So Jensen always talks about like extreme co-design, like designing the 6 or 7 chips together into like one system. How does like the MOE routing and the GPUs and the NVPF4 and all the things that you work with on the software side translate to the hardware side? I think that's one of the big misconceptions that I feel like investors and most average people fail to understand when they say NVIDIA sometimes has more software developers than hardware developers, and how that flywheel is sort of driven by hardware and software working together in tandem. Almost, yeah. I almost feels like it's like a yin and a yang relationship.
Yeah.
At the company, how they both kind of drive each other forward into this like perpetual motion. And I want to kind of dig a little into that, and like, how does it work between you and the different departments? Like, how does it flow through the company, and how does it permeate? That's what I'm interested in learning.
Maybe if you unpack the first point you're making, which is a very strong one, which is about the flywheel, right? Because that's how we started the GTC this year. Right? He said, hey, it took 20, right? Because it was 20 years of CUDA. And he said, hey, it took us 20 years to get an install base for CUDA. The install base has developers that drive innovations, that open up new markets, that drive more of a install base, right? So there's that data flywheel, right? The ecosystem flywheel, I should say, right? But notice here, we talked about software as part of that journey, as part of that story. So NVIDIA is a full stack company, right? Is a full stack company. We talk about the 5-layer cake, right? In terms of the infrastructure. And then we meet you where you want to meet us. We're all about the ecosystem, right? Jensen always, again, starts GTC, talked about the virtuous circle and the flywheel, and then showed the breadth of the ecosystem. We work with the ecosystem across all the different layers, and you tell us where you want to meet us. We believe if you go all the way up to the model layer, right? We partner for the agentic layer, but if you go all the way up to the model layer and use our runtimes, right? There are benefits that you get that translate to the best tokenomics that are out there. And those benefits are a result of the software and hardware co-design. So when you talk about NVFP4, right, it's about getting a model where you're not going to compromise much on precision, but it's going to run considerably faster. Right. And that is a hardware feature. And so, right, we aggregate it all, we build it all the way to the top, but then we disassemble it, right? And some people want to meet us at the Kubernetes layer because they want to have their own models on top of there. That's awesome. Some people want to utilize our models, right? That's great too. And so it's all about full stack acceleration, right? And the ability to meet you where you want to be met.
But like from a company perspective, sometimes people envision like one part of the office just software developers and the other part just hardware. But how does that like permeate throughout the organization
Oh,
to work? Like
yeah.
how it works is pretty amazing.
The mission is the boss, right? You'll hear that quite often. At NVIDIA, right? When we want to get something done, and we know that it's a full stack problem, we know you got to go all the way up the stack. It doesn't matter where you're working, who you're working for, right? If you've got the skill set, this is the priorities, it's been established, we get it done. That's how we collaborate.
So basically, in one room, you have all the stakeholders from the top to the bottom.
I mean, physically we can't all be in one room, but certainly when there are initiatives, when you're doing your stand up ahead of a GTC, right? Every morning, afternoon, evening, you've got the all the stakeholders on the relevant calls. We also do as much as necessary, as little as possible. So you want to allow folks to work and not necessarily always just be on phone calls. But I think you know what I mean.
So what do you think the gap in today's market? You see a lot of cool like agentic type demos from like your Salesforce, or we have agents for this and that. Like, when do we see real enterprise deployments, and what does that actually look like on the other end?
Yeah, great question. So this DeepResearcher that I just told you about, we have that deployed internally. And that is a swarm of agents that I deploy every time I need to do a deep research, synthesis analysis, understanding whether a product I'm about to release, or we're thinking about what are some gaps that I'm not, considering, what is competition saying, what does the ecosystem look like, what's the, right? So already I'm using a multi-agent based system internally, right? Another example that I like to talk about, because Bill McDermott of ServiceNow went public about this, and I know this because I got to work closely with those guys, is 90% of L1 tickets that come into the service desk are resolved by these L1 autonomous specialist agents. 90%.
Wow.
And so these guys aren't just giving you hints of how to resolve it. No, they will take the action on the back end.
Oh, so they actually orchestrate
They actually do the action, right? Right? They actually do the action, right? And then when they don't have a high confidence score in terms of how they're able to resolve it, they provide all that context, right, to the human engineer, the service engineer, right? And so the service engineer is focusing on the more challenging ones. So we're starting to see, Ben, autonomous agents, long-running agents take action. But I think our CISO, David Reber, does a fantastic job talking about this. When you start commingling external data with internal data and a coding agent, those three together, right, could be a recipe for disaster. So coming back to your point earlier of, hey, you got excited by this unbounded autonomy of OpenClaw, but no way you're going to give it your bank account access details, right? So I think and that's why we put out OpenShell. That's why the Nemotron initiative is there. It's about working with the ecosystem, right, such that we can continue to tap into and harness the utility of these long-running, self-evolving agents. Because when they have coding agents, they become self-evolving, right? Self-evolving agents, we got to figure out the compliance part. And that's why we have, OpenShell, which is, again, part of the NVIDIA agent toolkit. It's an open runtime that basically ensures that your agents runs within a sandbox. Mm-hmm. And the sandbox is a deny by default. So, Ben, you have to explicitly tell that agent that it can read your email, as an example.
I see.
You have to, right? So we're putting the policy guardrails in place, right? And I think that's the continuum we're going to see the enterprises on, which is long-running agents, right? And as they get more powerful, make sure we've got the guardrails in place to ensure that they don't,
because from where I'm standing, I haven't seen any large company really embrace OpenClaw other than OpenAI kind of absorbing it, and then NVIDIA trying to do this whole enterprise thing. And to me, it almost sounds like that moment in time when people were sort of jailbreaking their iPhones.
Yeah.
And it was like kind of like that rogue type of project. And But I remember when you would jailbreak iPhone 1 or 2 and you were installing those apps that people were making on the iPhone, that was the beginning of the App Store. Like you just didn't know it. And I think
Oh, interesting.
this is kind of sort of that moment of the fully autonomous agentic type of AI with the guardrails, but to make it fully adoptable for users and consumers, you have to kind of make it easy in a way to kind of click your way through and set up and not have the AI go uncontrollably wild, because it does make people a little scared with those things.
Yeah.
I think we're definitely early innings with that stuff.
Totally agree, right? Totally agree. We're definitely early innings, but I think, the same way I remember when Steve Jobs showed the iPhone, right? And my wife was very early on in the tech, so she got one, right? Right away, right? Got one. And I remember just being like, wow, right? But now when you look at it, you're like, oh, it's kind of, So I think we're going through a similar thing here. Like, this is that big of a moment. This is that big of a moment. The world woke up to what agents can do. Not respond to you via chat, but what they can actually do, what they can actually figure out by themselves. Because they're very good at, right, getting around and figuring out the problem. Because the models got good enough to and pretty much understand the corpus that exists on the internet. Coding, right, is the very first long-running agent, and coding is, right, if it compiles, it's almost deterministic.
Right.
And so, right, I think, that's a good analogy of where we were with the iPhone. I think we're just starting to scratch the surface with the agents.
But is there a way to create a verification layer for this like agent swarm of unleashing all these agents to make sure everything is right? Is that what you guys are working on?
I think, you have to have the instrumentation and the tracing in place to understand the reasoning trajectories. You have to have the policy guardrails in place for not just data, but also for network. You have to have routers in place to be able to determine what can be routed to a cloud endpoint versus something that might be local, right, on a Spark machine, especially if it's starting to tap into some of your personal documents, et cetera. So there's a lot we're excited about to do with the ecosystem in terms of making these autonomous agents be more deployable in domains that require a higher level of compliance. And so I think it's a combination of the sandboxing, the libraries for the instrumentation, the ecosystem for observability, right? The ecosystem for observability. That's the only way we're going to get to a point where we can trust these.
So this is sort of like, again, Jensen finding like a $0 billion market, right? To some extent. And then the funny thing is, and the way I see it is, this is another way to drive more inference usage, right? The more tool calls, more things you're going through, the more inference, the more agents, and it's like recursively using more tokens.
Look, agents will use a lot more compute, 100%, right? But our CEO's got a superpower to see into the future.
Yeah.
Right. Right. In 2018, if you go back and watch 2018, I think he was doing some GTC address where he described how he envisions his engineers in a not so distant future doing what they're doing today with Claude Code or Cursor or CodeRabbit or any of those, saying basically an AI is going to be writing the code.
Machine learning is one of the most important computer revolutions ever. Whereas computer scientists used to specify every single instruction a line at a time, now algorithms write algorithms. Software writes software. Computers are learning by themselves. Machine learning, the era of machine learning.
Because the AI can do it much faster.
Yeah, you said that, I remember.
Right? In 2018.
Yeah.
And so he's recognizing now, right? He's recognizing now the utility and the power, right? And engineers are now 10 times more productive, right? Our software engineers, 10 times more productive. And people who couldn't code in the past are suddenly builders. And so I think we're recognizing this opportunity with the agents. And yes, agents talking to agents is a lot more compute, right? But the compute, right? Compute is revenue. Like compute translates to tokens. Tokens is value add, is revenue. That's why they're calling them AI factories. And so, yeah, the compute, like I said, I think we're just on the cusp of the needs from a compute perspective, but it's an exciting path forward.
So like I feel like the future of the world discussion of everything is like the concept of tokenomics is like, it hasn't really even permeated Main Street language yet. I feel like,
I think it will. I think it will. And, with people like you and right telling the world, I think it will, right? Because look, if you're able to lower your cost of generating a token, and a token translates to, right, that you keep that delta. And so it is important that it's not just the, tokens per second throughput, right? It is a TCO play, and tokenomics are important. And so that's why it's a full stack acceleration problem.
So after these different Nemotron models that you guys came out with, obviously different sizes, what are you guys running to or working to next? Like, where do you see the next 5 years of what you're working on?
Well, I think what's super exciting is there was a time when you had to fuse models together for speech, as an example. An ASR model, right, for recognizing speech and translating it into characters. Then you had an LLM in the middle for the reasoning, and then you had a text-to-speech model on the other side. So you had a cascaded pipeline. I think what's exciting now is in my family, right, the speech-to-speech models really unlocked an ability to converse naturally, right? And so speech-to-speech models, the interrupt is natural, feels much more natural, and right, and so I think we're going to start. I'm excited about start seeing some of these world foundation models and what they could do. There's omni models, right, and what they can do. So more modalities, if you will, fuse into a single model, as opposed to these cascaded pipelines. I think that's what I hypothesize.
Basically, you see, I mean, I'm synthesizing this correctly, like multiple disparate models kind of working together in parallel.
Yeah, I think
to create like an outcome.
I think you'll have multiple models and multiple agents, right?
Wow.
Right. I think multiple models and multiple agents. We see this today. There's agents are systems of models, and so I think we'll continue to see specialization, and I think you'll see the convergence of open models and cloud frontier models, get smaller and smaller.
So I mean, that just keeps on driving the idea like we don't have enough compute. That's kind of what I hear from everybody in the industry. Is that how you feel? Do you feel like you have enough compute?
For my own personal use, I always want more. I always want more because it just makes me more productive. It just makes me more productive. We're lucky, right? We use AI, quite extensively at NVIDIA, and so I'm blessed. But I wish everybody else could have access to that tooling, and we envision that world. We'll get there, right? And so, as I said, I think it feels like we're just on the cusp.
And if you feel like I've missed anything, what else do you want to say in your final closing thoughts about, AI and the software stack that you guys work on at NVIDIA?
No, I mean, you're quite knowledgeable for you to,
really?
tap into. You understand full stack. You were talking about co-design, right? You're talking about co-design.
I thought everyone knew
extreme
this.
co-design and the tokenomics that we're talking about.
I guess they don't.
No, I think the point of you're asking, hey, are these being really utilized in the enterprise? And the answer is yes, right? I go back to the example that I gave, which is software engineers don't actually want to be typing. Like, that's not what they get out of bed because they want to type the code.
Right.
Is they want to build things. And so I think what I'm excited about is how we're going to impact the rest of the knowledge workers. I don't actually like doing the research synthesis when I'm thinking about products and stuff, right? I want to think about it. Right? I don't want to look for the for the info. I want it to be brought to me. I want to think about it. And so that's what we're excited about.
Yes, I do envision what I guess Jensen was still saying. It's like the iPhone and everything made us more busier, and I think AI will probably make us do more in less time. So make us more productive and everything. So really appreciate your time.
Yeah, thanks for having me, Ben. Yeah, it was great.
Thank you for joining the NVIDIA GTC live podcast in San Jose, and hopefully to see you soon at future events and following you on. I think you're pretty active on LinkedIn. I see a lot of your posts, and really appreciate you sharing your journey and where this is all headed. It's really exciting, an exciting time to be here at this moment in AI and technology.
Couldn't agree more. Thanks for being here.
Thanks.
All right, cheers.